All right, you guys, now we're going to compare distributions of a categorical variable. So when you guys are doing goodness of fit, again, you're comparing to a known population. Now we're going to actually take two different categories, and we're going to see how alike the distributions are. So for example, I might take 50 girls and 50 boys and compare what TV shows they like, or something like that, all right? So I compare the distribution among two different categories. So there's not one that's like the right answer versus the not right answer. Does that make sense, you guys? Okay. So here's an example. Does background music influence what customers buy? So we're at a restaurant in this problem. All right. Market researchers suspect that background music may affect the mood and buying behavior of customers. One study in a European restaurant compared 3 randomly assigned treatments. So in the restaurant, they played no music, they played French accordion music, and Italian string music. All right, no music, French music, Italian music. And did that affect what they ordered for their meal? So under each condition, the researchers recorded the number of customers who ordered French, Italian, and other entrees. So just another reminder, sorry, interrupting this example, but chi-square test for goodness of fit. So again, this is like the M&M's claim versus what's observed in the bag. Or if we have a dice and we know the distribution should be a 6, okay, versus chi-square test for homogeneity, which compares several distributions to each other. So I might take the bag of M&M's and compare it to like peanut M&M's and see if the distributions are similar or not similar. Back to our problem. So here we go. Types of music. Calculate the conditional probability in proportions of entrees ordered for each restaurant. So what you want to do is look at the treatment. So this treatment is none, all right? So basically there were 84 people in the restaurant at the time when there was no music playing, right? 84 people. And I want to know, given there's no music, what's the likelihood they would eat a French meal? And then what's the likelihood they would order an Italian meal? And what's the likelihood they would order an other meal? Conditional probability, you guys, is a given something. So for the first one, we're going to do no music and French, or just looking at no music French. So out of this one, we've got 30 people out of 84 who ordered a French meal. That's a conditional probability, which is 0.357. Okay? And then no music who ordered Italian. Well, that would be 11 out of our 84 people, so 0.131. And then other with no music, 43 people ordered other, and we get 0.512. All right, and then French music. Well, now I'm going to look at the middle category here. And while they're listening to French music, 39 out of 75 ordered French meal. 1 out of 75 Italian. Nobody liked Italian on that one. 35 out of 75 on an other meal. And then same thing here, we're listening to Italian. We would do 30 out of 84 who ordered French, etc., etc., and you'd get all of your decimals. Okay, so I just made probabilities. And then we've got a lovely bar graph to compare our distribution. So this is not yet our test. Okay, we're just looking at our different distributions. So it's hard to read, but this one is what? No music? I can't even read it. French music, yeah, Italian music. So this one's no music. This is French. This is Italian. So everybody look at French food. So this is what they ordered. French ordered. What happened to the French, the orders of French food, when I compare no music, French music, Italian music? Is there really a difference? A little bit, but not a huge difference, right? Okay, so when we compare these distributions, not a huge difference there. How about Italian is this middle one? So Italian, no music. Italian orders with French music, and Italian, well, listening to Italian music. Is there a pretty big difference there? Yeah. So definite increase here. When they were listening to Italian music, more people ordered Italian food, okay? And then the last one is the other. So ordered just a generic meal, probably American or something. So those are all pretty much the same, right? Didn't matter what we listened to. So when you write something up, right, this one says write a few sentences comparing the distributions. Few sentences. Few sentences. You guys gonna be all right? All right. The types of entrees that customer order seems to differ considerably across the three music treatments. Orders of Italian entrees are very low, 1.3%, when French music is playing, but are higher when Italian music, 22.6%, or no music, 13.1%, is playing. French orders seem popular in this restaurant as they are ordered frequently under all music conditions, but notably more often when French music is playing. And for all three music treatments, the percent of other entrees ordered was similar. All right, so that's 4 sentences. You guys write 4 sentences. Malcolm. Yeah. Mm-hmm. All right, so that's just comparing distributions, you guys. You can do bullet points. All right, just say some comparison words. I think you guys will be all right. All right, I would write this in your notes, you guys. This is kind of the generic what you do for the null and the alternative hypothesis when you're doing a test for homogeneity. All right, and when you do this test, again, it's when we're comparing two different distributions, and one of them is not the right one. It's just, are they similar or not? So maybe I took 100 boys, 100 girls, and compared them. So for the null hypothesis, there is no difference in the distribution of a categorical variable for several populations or treatments. I would just say no difference in the distribution. Comparing, maybe you could say comparing populations or whatever. Okay. And then, of course, for the alternative, there is a difference in the distribution of a categorical variable for several populations or treatments. Okay. So it can still be a sample or it can be an experiment. Treatments is the experiment. Yeah. Yeah, that wasn't even the test. That was just comparing distributions. No, they're different problems, so they won't be combined. Yeah. Part A through 20. So after you do your state part, which is where you do the hypothesis, and you should probably put your significance level of 5%, because they usually don't give it to you. Then you do the plan part, right? And the plan is all the same, except for expected counts or large counts is different. So that's why we're going over how to do large counts. Large counts is kind of a pain in this one. All right, so the null hypothesis in the restaurant we just talked about, so that would be there is a difference in the distribution versus there's no difference. So the null would be no difference. The alternative would be there is a difference in what people order based on the music. So to find expected counts, we start by assuming that the null is true. All right, so if the null is true, it doesn't really matter what music we're listening to. And we can see from the two-way table that 99 of the 243 entrees ordered during the study were French. Okay, so if I just look at total, 99 out of 243 were French. So let's say I go in on a no music day. Okay, that means that 84 people were in the restaurant. If the music doesn't matter, then the proportion who order French food would be 99 out of 243. Does that make sense? Okay, so on a day with no music, there's 84 in the restaurant. If music doesn't matter, you would multiply that by 99 over 243. And that would give you just one expected count of 34.22. That would be this number right here, would be your expected count for French, ordered French, and didn't listen to any music. Okay. So what if I want to do French, orders a French meal, and French music? So I come over to this guy right here. Okay. So now I'm looking here. Now I'm going on a day when I'm listening to French music. All right. So there's 75 people in the restaurant this day. And if it doesn't matter, right, if it doesn't matter what music is playing, then I should multiply that number by 99 over 243 to get how many would order French. So it would be 75 times 99 divided by 243. And we would get 30.56 for this specific number. Now, there's a pattern that you might be noticing. Let's say we do the next one, French, Italian music. So this time I go in on a day, we're listening to Italian music, and there's 84 people in the restaurant, right? And what would my expected count be? Well, if it doesn't matter how many would order French food, so it'd be 84 times 99 divided by 243, and we would get 34.22. All right. Anyways, what are you noticing is the pattern. Anybody see it? Well, yeah, they're going to add up, yeah. What if I do this one? Let's say I do this expected count. So again, I go in on a no music day, so I'm going to multiply 84 times the proportion who would order Italian if it didn't matter. So that'd be 31 out of 243. So you would do 84 times 31 divided by 243. So here's the formula, which is much easier than trying to just figure out what the heck you're doing in the two-way table. So anytime you do expected count, it's the row total times the column total divided by the table total. That's how you'll find any expected count. How many expected counts are there? Well, if you go back to the lovely matrix, you're going to have to find all of them. Don't do the totals. So there's 9 expected counts. All right? So if I'm doing this 11 one, again, I'm doing row total, so 84, or column total, times row total divided by total total. Okay, so for 1, what am I going to multiply for this guy right here? 75 times 31 divided by 243. How about this guy? What would I do? 84 times 31 divided by 243. How about this one? 84 times 113 divided by 243. Everyone see what's happening here? Okay. That's how you get every single expected count, and you'd fill in this lovely table right here. And so every single one has an expected count. Everyone get how we got these numbers? If you don't, make sure you write this down. Row total times column total divided by the table total. That's right. We're looking for at least 5. So do we have large counts on our music problem? Yes, we do. Also, use decimals. Just a reminder, if you don't use decimals, they will count you off, all right, on the test. Yes? That's a great question. I haven't had one yet, so I'm not sure. Proceed with caution. Just kidding. I don't know. Yeah. 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 Yes, they should be random samples. All right, the chi-square test statistics. So after you do the plan part where you do random, 10%, and that whole expected counts thing, okay, then you got to do the chi-square test statistics. So you guys hopefully have this kind of formula down, right? So it's the sum, and here's the symbol we use, chi-squared. So it's the sum of the observed minus the expected 30 minus 34.22 squared divided by the expected plus 39 minus 30.56 squared divided by 30.56 plus dot, 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 right? Because we're going to do this on our calculator, of course. You could do it that way, though, but that would be like a bunch of stuff to enter in your calculator. By the way, do we use the total columns or rows? No. Be sure you only use these 9 numbers with these 9 numbers, okay? So let's go ahead. Oh, degrees of freedom, by the way. Because eventually we'll need degrees of freedom when we do the calculator part, we got to know degrees of freedom. So degrees of freedom is the number of rows minus 1 times the number of columns minus 1. When you do rows and columns, you guys, don't count the totals. Again, this is basically a matrix that is 3 by 3. Okay? So there are 3 rows and 3 columns. So 3 minus 1, times 3 minus 1 is 2 times 2, so my degrees of freedom for this problem would be 4. Does our calculator do this for us? Yeah. Yeah, it does. All right, this is a little challenging. If you have the 84, you should definitely just turn to where it is in the book because, yeah, you're going to have to go to matrix and stuff. It's not too bad, but if you have the Inspire, you may follow along with me. So the first thing you want to do is go to a home screen, and you're going to name your matrix, and we'll just call it music. And let me get my calculator open. Inspire people. Type in music or whatever you want to name your matrix. Okay, just type it in with the letters at the bottom. All right, this button is what you're looking for. It's got a colon and an equal sign, and you have to press Control, and it's right above the matrix key. So you press Control, and then this colon equal sign. Right here, Control and this colon equal sign. Make sure you know where that is. Charlie, do you have it? You got it on there, though? Okay. Then you guys go to this matrix button that's right below what you just pushed. Yeah, it's the same button. Okay. Then you go to this guy right here, your matrix. Click on this one. All right. 3 by 3 one. And then it's 3 by 3. You can change it from here, though, right? If you need a 2 by 3 or whatever it is. So here's a 3 by 3. Press OK. And you're going to enter in the original, the observed matrix. So 30, and you press Tab to get to the next box, or I guess the arrow key works. 39, 30, and let's type in the whole thing. 11, 1, 19, 43, 35, 35. And then just press enter, and it saves it as a matrix. Okay, you guys, so then go to menu. Go to statistics. Go to stat tests. David, are you doing this with me? Okay, so last time was goodness of fit. This one is a two-way test. So it's the chi-squared symbol, and it's a two-way test. And you put observed matrix, music. Whatever you named your matrix. Press OK. So it gives you this chi-squared is the test statistic. So you guys, that number is what we would have gotten from this formula right here. And so you'd want to put that number in 18 point, what was it, 26? 27. Okay, 28, I don't know. So you'd put that in for your chi-squared test statistic. And then you can do the p-value, which we're going to need. And the degrees of freedom is 4. There's a couple things that this does for us that's very helpful. So everybody listen, because it will find the expected count matrix for you. You guys ready? Press var. Right here, var. And it has the component matrix, which is helpful, and the expected matrix, EXP. Click on the expected matrix and press enter. And it gives you all those row times column divided by totals, okay? Go to var and component matrix. And this tells you which one messed it up the most. So when you're doing your follow-up analysis, that's what you use. Which one of these has the highest value and messed it up the most? 7.67. What one was that, right? So that was like Italian music, Italian food, right? Or something. Oh, French music, yeah. So then you look at where that comes from and you talk about that in your matrix, okay? Everyone good on that? I hope so. All right. So p-value and conclusion, you guys. So for interpreting the p-value, some of you still don't know how to interpret the p-value. Assuming there is no difference in the true distributions of entrees ordered when no music, French music, or Italian music is played, there is a 0.011, that's the p-value, probability of observing a difference in the distributions as large or larger than the one in the study. Interpreting the p-value. So it's the probability of getting a difference as large or larger. It will always be as large or larger on this one. Okay? And then for part C, what conclusion can you draw? Well, because the p-value of 0.00, I think I did that. Is it 0011? Anyways, is less than 5%, we reject the null. We have convincing evidence of a difference in the true distribution of entrees ordered at this restaurant. So there is a difference. By the way, did we have random assignment in this study? We did in this study. We had random assignment to the treatments. So that means that the difference is actually caused by the music. So if you have random assignment, then you have causation, all right? So random assignment means you can make cause and effect. All right. So let's do one more, just the calculator part maybe. No? No? You guys want to just try the one on your sheet? We'll do that. All right.